This meeting.
From yesterday class, we discussed about having inter-VLAN communication with the router. And when we have multiple paths, we have four conditions. One is longest prefix match. The second condition is administrative distance. And the third condition is metric. And the fourth condition is equal cost multipath load balancing. So now let's do a question of having multiple routes and then see what path will be selected by the router in order. So the source is destination and this is router. Okay, this got many paths to the destination. So let's say this is trying to go to destination of 192.168.1.1/32. So router has to go to this destination. It has available paths. Let's say there are 10 available paths. Path A. So here, online. So anything. Okay, so there are A to L routes. So now we have to select the best path to the not so effective path, right? So you should start from writing the best path. Let's say if the best path is A and the second best path is C, so you have to put it in the order. So go from assigning all the way to designing order and then put your answers in the chat. So this source is trying to go to this destination and you have to tell me which one is the best path. So this is all 192.168.1.1. So it's not 1.0, it's all 1.1. Okay, don't worry about 1.0, it's all 1.1. You got the question? Can someone acknowledge? Did you understand the question?
Yes.
Yes.
Okay. Don't just put what is the best route, just put order from best path, second best path, third best path. It has to be like, let's say if your best route is E, the answer starts with E, and the next route is G, the next row is G, and next I, like that. I got only few answers. Come on, I want answers from most of you guys. Please try. Just don't sit and relax. Three more minutes, guys. 3 more minutes. Last minute. Okay, let's see. So 192.168 1.1/32. So in this case, we have to go with the longest prefix matches, right? So if you observe, there is 1/32 and the other /32. So the G and I are the /32s. So these are the most longest matches for the destination, right? So it will be a tie between G and I. Now next one is like static and IBGP. We know the static is the AD value of 1 and IBGP is 200. So I will be the first route. I will be the first best route. And then after that G. So after /32, we have a /31 here. We have a /31 here. So it is a tie between C and H. Now C is a connected route. Okay, so that means 0. So C will be the AD value of C and then the H. Okay. /31 is done, now /30. We have D is there and we also have J is there. So D and J both are EIGRP routes. right? And then if you observe the metric of this one is 10 and metric of this one is 100. So lower metric wins. So that comes the D. And then J. Okay. So slash 30s are done now. Now we are going to slash 29s. We have a slash 29 here. Now only one slash 29, that will be F. Now we have slash 28s. We have B. Only one slash 28. Okay. Now slash 27s. Nothing. Slash 26s. We have one slash 26, which is L. Yeah, I don't see any slash 26. So next we have slash 25. Nothing. No slash 25. Next we should have slash 24. So let's see. 1, 2. Okay, we have 2 slash 24s. One is OSPF, another one is ISIS. OSPF value is 110, ISIS is 115. So AK. K. What else we left with? Slash 21, nothing. Slash 22, nothing. Sorry, slash 23, nothing. Slash 22, nothing. Slash 21, nothing. Slash 20 is there, which is E. Okay. So IGCH, DFJ, BLAKE. If you got this answer, you're right. I hope most of them got the same answer and they followed the same methodology. Any questions, guys? Yeah, if I observe the answers, I think most of the guys said the same thing. Okay. It looks like you got the concept nailed. That's good. Okay, we'll move on to the next step, guys. Any questions? Okay, cool. So we are going to the routing protocols now. When we have right now we talked about inter-VLAN routing, right? Till now we talked about we have only one router, like so we have one router, and then we have one switch or two switches, doesn't matter, but I'm going to just take one switch. And then we have PC1, PC2, PC3, and we have connectivity. So all these species connects to the switch. Switch connects to the router. So router, switch, PC1, PC2, PC3. So let's say this is in VLAN 10, this is in VLAN 20, and this is in VLAN 30. VLAN 30. So now these are all networks connected to this switch in different VLANs, and this switch is connected to this router. So this router can do the inter-VLAN routing with the help of a router on a stick. So the gateways will be configured here, and this router can make these VLANs communicate. But what if there is another router and they have another switch and they have another 3 PCs? They're in three different VLANs. So this router and this router should be communicating with each other, right? So that this PC will be talking to this PC will be talking to this PC. There has to be a way this router should be able to communicate with this router, right? So for that reason, we need a routing protocol. So to make two routers communicate between them, we should have routing protocol. So there are two types of routing. So we can manually put the route, like if you want to go to this PC network, just put the router as the next hop. So it's a manually adding a route on this router that if you want to go to this network, go to this router IP. So you can manually put that. Or you can make a dynamic neighborship between these routers, like a relation between these two routers, and whatever networks are there, this router will tell to this router, and whatever routes that are there, networks that are there, it will send this router will tell to this router. So this is called neighborship. So just think like there are two persons, and these persons know about 1,000 people data. Okay, and there is other 1,000 people data is known by this person. Okay, so there is one way that if you want to reach any of the 1,000 people, we can point this router point into this person manually. Okay, so we have to manually go to this person and tell, okay, if you want to go to any of the 1,000 names, just go to this person. We can manually tell to this person and then manually update him. Or we can make this router and this router friends, or this person friends. And once they become friends, they'll exchange their information about these two persons. So if let's say someone else is added, like 1,000, one person is added, this router will automatically tell to this router, or this person will automatically tell to this person without we adding manually that person list. Let's say one person is removed from this person, only 999 persons are there now. Because these are neighbors or these are friends, he will automatically tell to his friend. We don't have to manually tell him again and going. So that is the concept of static versus dynamic. So static means we are manually putting a route. If you want to go to that network, go talk to this router. That is static we are putting. But if we make two routers neighbors, then they will automatically update their information to the neighbor without manually updating them. So that is the difference between static routing and dynamic routing. Any questions? Okay. All right, now let's talk about one of the dynamic routing protocol, RIP. Okay. RIP is a routing information protocol. So RIP will work on the number of hops in the information. So basically, let's say this router So for this router to go to the destination, it is taking first hop, second hop, third hop, fourth hop, fifth hop, and the destination. So it's taking 5 hops to reach the destination. So for this one, it's taking first hop, second hop, third, fourth, fifth, sixth, seventh, eighth, and ninth. So taking 8 hops is the destination. So RIP will make the neighborship between R1 to R2, R2 to R3. So the R1 will be neighbor of R2, R2 will be neighbor of R1 and R3, R3 will be neighbor of R2 and R4. So R1 to reach the destination, it has 5 routers to pass through, but R1 to go to destination, it has to pass through 8 routers. So now with the RIP, it will select the best path with the path 1. So this is the path 1. It will select the best path because it has the less number of hops. So if the path path 2 is higher, this will not choose the path because this will be the higher number of hops and it is like a backup path on the RIP. If let's say if the primary path fails, like if some router went down, then the RIP will inject the second route into the routing table because the second path is available with 8 number of hops. So just like, think about like if you want to go from one city to another city, you booked a flight. These are number of these are number of stops in your flight journey. So you are having layover 1, 2, 3, 4, 5 layovers here. But here you are having 8 layovers. So you'll obviously pick the 5 layovers time because the less number of hops are there. Okay, so that's why it's called a distance vector protocol. Okay, but this is not advantageous because so it is just looking at the number of hops. But what if this layover time is like what? 5 days. But here every layover time is only 1 hour. But here you're waiting 5 days if you go via this router. So this path is not considering a factor called time, right? There is no time factor. Let's say if the packet is going via this way, if the packet is taking 100 seconds, but if you go via this way, if the packet is taking 2 hours, obviously it should go via this path, even though there are a number of hops more, but this should be the primary path. But RIP doesn't consider that. That's why RIP is not most commonly used. RIP is like an older version. No one in the corporate networks that I have seen, except for a smaller networks, they don't use RIP. Mostly people use OSPF or EAGRP. They don't use RIP, but RIP is there in the syllabus, so that's why we are talking. Okay, any questions on what is the distance vector protocol and what is the condition for the election of the best path in the RIP?
Sir, one point I did not understand. To know the best path, you need to have the information. When the source don't have the information, that's what it is traveling to all the routers, right? So how it is going to identify which is the best path?
So this router will inform this router that this got the destination. This router will say, I have 1 hop to reach the destination. This router will say, I have 2 hops to this router. This router will get information from R4. This router will get from the R3. This router will get the information from the R2. So every router will pass the information to the next router that will go to the source. Think about people sitting in the line. This person informed message to this person. This person will tell the information to this person. This person will tell the information to this person. This person to this, and this one. So it just passes the information. Is that clear? Or is that your question?
Yeah, correct. That is my question. But see, even routers don't have that information until you get, if it is going to check in that information. Routers don't have the information until switch communicates to the router exact, right, sir, sometimes. If routers don't store the MAC information and all, if I'm going to for one IP, but until you go and if routers don't have that information, again, it is very hard to understand which one is the best way until you go and search, and you'll go to one router and router goes to switch and see that a LAN is there or not, or that details.
We are not talking about LAN. We are not talking about searching of the addresses here. This is purely routing. We are talking, if router knows that information, it will pass. If the information is not there, it will never pass to the next router. Your question is vague and it's not valid to the topic. Reason why is a router will know the connected neighbor with the help of the RIP. We are not talking about destination here. We are talking about two neighbors forming the RIP neighborship, and they will pass the information once the neighbor is formed. For example, in your use case, let's say there is a router, it has a switch, and it has 3 PCs. Okay, so this router is there, it has a switch, and it has 3 PCs. So once if you form the neighborship of RIP between these two routers, whatever information that this one will have will be passed to this router. So this router is the gateway. It should have all the information. So the question you're asking some routers doesn't know is invalid.
Yes, sir. Yeah, I understood now what you're trying to say.
Okay, so going back. Okay, so okay, so we are talking about the disadvantage of the RIP, right? So let's say if the path is chosen, the best path is this one with 5 number of hops. If the other path is there, it is also 5 number of hops. Then what will be the condition? So then it can choose any of the path. It can use load balancing with the ECMP. When the paths are equal, the RIP does the equal cost multipath because both of them are same number of hops. Then it can choose one of the path. Okay. So that is how the distance vector protocol works. And there are two versions of the RIP. One is RIP version 1 and the other one is RIP version 2. So now let's talk about the differences between RIP version 1 and RIP version 2. So this router is neighbor with this router with the RIP version 1. This router is with this neighbor with RIP version 1. So because these two are the RIP version 1 neighbors with this router, let's say this one is R1. So when this route sends the information to this router, it will send the route as 192.168.1.0. But it will cut off the subnet mask. It will never send the subnet mask. So even here, when it's sending the information, it will send 192.168.1.0. So now will RIP 1 uses path 2 or path 1? Anyone in the class?
We cannot choose the best path without subnet mask.
I'm asking Sirisha, there are two paths. Path 1 is 192.168.1.0. Path 2 is 192.168.1.0. Now, router 1 will consider which as the best path.
It can choose any path.
Yeah, it can choose any path because the subnet is discarded, right? It can choose any path. It can do load balancing between both of them because both of them are equal, right?
Yeah. Yeah.
So that is a disadvantage of RIP version 1 because it is not sending a subnet mask to the neighbor. It is a classful routing protocol. It does not advertise the subnet mask information to the neighbor when became the neighbor. So originally, if we observe, so this one is what? A /24. This one is /28. Which one is the best path?
28.
28 is the best path because of the longest prefix match, right?
Yes.
So,
Yeah.
but because the RIP version 1 is cutting off this subnet mask, these routers, when become the neighbor, is not sending the right information to the router 1. So it will choose both of the paths and eventually it's not choosing the right path. So that is the disadvantage of RIP version 1. It is very, very old. That's why they came with the version 2. The version 2 is classless routing protocol. It is capable of advertising the subnet masks, meaning when this router is sending information to this one and this router is sending information to this one, this will send information like 192.168.1.0/24. And when this one is sending the information, it will send 192.168.1.0/28. Now, which one R1 will choose?
/28.
Second path. Yeah.
/28 by R3 and goes here. So the RIP version 2 is a classless routing protocol. It is capable of advertising the subnet mask information. RIP version 1 is a classful routing protocol. It does not advertise the subnet mask information to the neighbors. Okay, so that is about the RIP version 1 and RIP version 2. Okay, and there is a limitation on the RIP, guys. So let's say, any questions before I move to the next topic in the RIP? Okay, all right, so So these are all RIP neighbors, okay? So these two are RIP neighbors, these two are RIP neighbors, so on and so forth. Everyone is a RIP neighborship between them. So if the destination IP is known to this neighbor, so this one is directly connected route, right? So this one will say I am the route of 192.168.1.1/32. Okay, so this destination route is known by this router. So now this became the RIP neighbor to this one. So this one will know the route. This one will give the route to this one. This one will give the route to this one. This one will give the route to this one, and so on and so forth. So, but if you observe, the source is here. When it's try to look for the information, if you see how many hops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 hops away, right? So from the source, it's trying to go to this one with 18 hops away. But RIP has a limitation of only 15 hops, meaning it can query only up to 15 routers. But once it passes that, the request cannot be sent to the next router, and this one cannot be forwarded the information. So if this one is sending the information to this router, right? So this one will be gone, this one will be gone, this one will be gone. So the routing information will only pass it up to 15 hops, but it cannot pass up to the 16th hop because the RIP has a limitation of only 15 hops. That's why RIP is only used in a smaller networks where there are not more than devices which cannot support more than 15 networks or 15 routers, right? So if it's larger than that, your communication will not be achieved with the help of the RIP. You need to have some sort of other routing protocols to accommodate that. So RIP has a limitation of 15 number of hops. And also RIP has a limitation of updating the routing table. Let's say, any questions on this topic before I move to the next one? Okay. Let's say there are 100 networks here. And let's say there are 100 networks here. These two are RIP neighbors, RIP version 2 neighbors. Let's say we removed one of the network here. We reduced one network to 99. This router will not immediately send the information to this neighbor. It will take 30 seconds to update that to the neighbor. In that 30 seconds, if anyone wants to send the information to this router, it will still think that it is available and it's trying to send. That will fail. So the convergence time, the sync of information between the both routers will be taking 30 seconds to sync. So let's say in that 30 seconds, if we are hosting something like Netflix.com, if Netflix.com is moved to a different server, this one will not update to this router, and all the people in this region will try to hit the old Netflix server. Then they will not get the Netflix for that period of time, and it's a big outage, right? So it's not very real time. The updates will not be synced faster. So RIP will take 30 seconds, which can consume a lot of bandwidth, leading to a slow network convergence. So that is also one more disadvantage. It is not like fast enough to converge to accommodate the fast-paced networks. Okay. Any questions on that? Okay. All right. Let's see. Akash, can you tell me difference between classful and classless? Akhila. Anirudh. Bhavana Lucky.
Sir, can you please repeat the question?
What is the difference between classful and classless?
In classful, there will be no subnet sent. In classless, the subnets will be sent so that it's easier to choose the longest path.
Yep,
RIP we were
yeah, in classful, we are not sending the subnet information to the neighbor, so it will be not feasible solution to choose the best path, whereas the classless is a RIP version 2 that will elect the best path with the help of the subnet information which is being passed to the neighbor. Okay. Akash, Akila, Anirudh, I don't know what you guys are doing. Please pay attention to the class. Bhumika, what is the limitation for the RIP version 2 in terms of number of hops?
Sir, it can only transfer up to 15 routers, not more than that.
Yeah, the limitation is 15. What happens if it's past 15?
It will not form neighborship with those, and
It does form the neighborship, but the packet will be timed out, expired.
okay.
The neighborship will
Okay.
be there, but the information will not be passed because it is 15 hops away.
Okay. Thank you.
Okay. Dilip.
Yes.
If a router wants to select the information from the RIP version, what is the time it takes to update the database?
30 seconds.
Yeah, if there is any change, it does take 30 seconds of time to do the
To update that information. So before that, it may be loss of information. So you
Okay.
still want to, yeah.
Shravan, what is the AD value of RIP?
What is the AD value of
RIP. Vinesh Reddy Palla, what is the AD value of RIP?
120.
Yeah, 120. Okay. Vishnupriya Palepu, will the lower AD value is preferred or higher AD value?
I think lower AD value.
Are you sure?
Yes, sir.
Yeah. Lower AD value is preferred.
Yeah.
Higher is not preferred. Correct. Okay. Sonayana, is RIP version 2 classful or classless?
It's classless, sir.
Yep. RIP version 2 is classless because it will be capable of sending the subnet information. Okay. And Shami, what is the major disadvantage of the RIP? Shami? Richa, what is the major disadvantage of RIP?
Yes, sir. Major disadvantage of RIP is like its maximum hop count is 15, so it cannot reach the beside that. So it can be used only for the smaller network. And the second disadvantage of the RIP is sometimes when the hop count is not the sorry. Sometimes it's not the shortest path because of the count, because of the count. It may be closest. Closest may not be shortest, and choosing the closest path by the hop count does not necessarily means that it's a fastest route. Sorry. So
Yeah,
these are the
that is the major disadvantage. Like choosing the path with number of hops may not be the best path because the less number of hops
Yeah.
may lead to more time, right? So it is not considering factors like the speed of the packet, delay in the packet, all of that. That's why it's not a advanced distance vector protocol. Okay. All right.
Yeah.
Okay.
Sorry, I'm not well. My voice is not.
Now you're good. Thank you. All right. That's all, guys. I'm going to stop the recording. Any questions?